So today the screencast is going to be about how you can graph a linear equation that is in slope-intercept form. So before we start that, we have to talk about first what these keywords are. Our keyword first is an axis. So on a graph you have two axes. You have the x-axis and the y-axis. And so when you look at your graph over here, the x-axis is the one that goes straight across side to side, and the y-axis is the one that goes up and down. These are going to be important when we are plotting our points to be able to graph this in slope-intercept form. So another keyword here is slope. So slope is going to be your rise over run. And another way to describe slope is that the slope is what's happening. It is your rate of change for your graph. So it's either going up or it's going down. And then the other important word that we have is our intercept. So our intercept is our start, and it is when x equals 0, we have to figure out what y equals. And a cool thing is, in these equations, it's actually giving us the slope and the intercept, and that's why it's called slope-intercept form, so we don't have to calculate anything for those. So if we're ever not sure, we can also make tables of values, but right now we're going to talk about how we can graph them. So looking at our first equation here, we have y equals 2/3 x plus 1. So when I'm looking at my equation, I know that my slope is going to be my rate of change. So the slope is going to be that number with the x. So this here is my slope. And then my starting number, or when y equals 0, or when x equals 0, I have this number here, which is my y-intercept. We also like to call that our start number because that's where we start on our graph. So if we come over to this graph here and we look at where we want to start, we are going to start on the y-intercept of 1. And then our slope is 2/3. And we already discussed that that was rise over run. So we think of that like stairs. We're going to start at that point that we already put on there. We're going to go up 2 and then over 3. So I go up 2, over 3. I draw my new point. And I can keep doing that just like I would just going upstairs. I'm going to go up 2 and over 3 again. And as many times as I can do that on my graph, I'm going to do it. Up 2, over 3 again. And now it seems that I've run out of space because if I go up 2 and over 3, I end up somewhere out here and I can't really calculate that very well. So I can test that again over here on my table. So if I have my equation 2/3 and I replace the x with any of these values in my table, so if I replace it with 0 plus 1, I calculate this, I get an answer of 1. If I do that again, 2/3, and then I replace it with a 1 plus 1, I end up getting 1 and 2/3. And I can continue to fill in this table. The next one would be 2 and 1/3. But these are numbers that I can't really graph. So if I look over back at my graph, I don't have a dot on the 1 or the 2 because I don't really know how to graph 1 and 2/3 or 2 and 1/3. But if I keep going through this strategy here, and I get 2/3 times 3 plus 1, I get an answer of 3. And that's something that I can graph on my graph, which you see over here, I have a point at 3, 3. So I can take a ruler and draw a nice straight line through my points. Let's see if I can draw a line here through my points, and I get my graph. So the next one that I'm going to look at is this equation here of y equals 8 minus 4x. So my first equation, the slope was the thing that came first, and then the y-intercept came second. But the only reason why that the slope came first was because that was the first number that I had. That was the first one that had an x with it. So when I look at this equation, I have this minus 4 attached to my x. So my slope is going to be that minus 4. And that means that my 8, which is a number by itself, is my y-intercept. So if I want to graph this, I know that my slope is rise over run, and I have a negative 4. But then I'm thinking, I don't know what my run is if my rise is 4. So if there's ever not a fraction for your slope, you can make that a fraction by putting a 1 underneath of it. So negative 4 is the same thing as negative 4 divided by 1. So when I go to graph, I know that I'm going to start my y-intercept of 8, and then I'm going to do a rise of negative 4. So it's not really a rise, it's a decrease of 4, and then a run of 1. So it's almost like I'm going down the stairs this time. I'm going to go as far as I can, and I seem to run off of the graph here, so that's what I can do. So then again, I can take a line tool, and I can draw my line through my points, and I get a nice line. So if I'm curious, I can always come back and fill in my table again by plugging in the points. So I'm going to do this over here where I have some space. 8 minus 4 times 0. 4 times 0 is 0, and then I have an 8. I can do the same thing. 8 minus 4 times 1, I get 4. 8 minus 4 times 2, and I get 0. 8 minus 4 times 3 gives me negative 4, and 8 minus 4 times 4 gives me negative 8. And so I can see those points reflected on my graph. So the last thing I want to show you guys is that there are 4 types of slope. We have seen 2 of them so far. We saw a positive slope that went from the bottom to the top. I had a negative slope, which was the second one that went from the top down to the bottom. So it's like I have going upstairs and then I'm going downstairs. A zero slope is like if you were on a flat surface. So zero slope is going directly side to side. Nothing is changing in my zero slope. And then undefined is the trickiest one because undefined is like falling off a cliff. It is going straight up and down. So it's almost like there is no slope at all. And that's it. So hopefully this helped you.